All right. Good evening, ladies and gentlemen. Okay, this is our second last class. Okay, next week we will talk about all of the possible come-up question, all of the questions that you need to be aware of, structure questions, essay question, especially. That is our next week lessons. Okay, of course. What we do today is we are going to discuss something that are going to possibly what happens in your paper 3 lah. Right? Structures of whisking tubing, talk about plasma membranes, talk about the permeability of a membrane. Now, in your paper 3, ladies and gentlemen, paper 3 is hands-on paper. You all know that it's a hands-on paper. But, you know, what is the purpose of a paper 3? Right? You must find out. Okay? So in this question, I give you an example. These are questions that in 2023 para questions. Okay? In para question 2023, right? So we wanted to know what will happen and what is happening. So, ladies and gentlemen, first thing that you take when you take this paper, right? Look for this. Based on the information, conduct an experiment to investigate. This is the purpose of the experiment. All right? So whatever later we want to find out, we have to go to the purpose. Hypothesis, go to the purpose. All right? Manipulated variable, go to the purpose. Responding variable, go to the purpose. Okay? Conclusions, go to the purpose. Okay? Your results, go to the purpose. What is the purpose? So I would suggest people to highlight, okay, what they want. Investigates the movements of substances across the selective permeable membranes. Okay. Investigates the movement means what? Means is this item able to move in? Is this item able to go to this? So that is investigations of movement. Can go or cannot go, right? It's not how fast, it's not how slow. How fast, how slow, they will tell you, right? Investigate means who can pass through, who cannot, all right? Movement across what? Movement across the selective permeable, right? You can write selective permeable, or they will use something similar, partially permeable. I always like to use partially. That means some substances can pass through, some substances cannot pass through. Partially permeable, right? Or if it's not partially permeable, what kind of a thing they can say? Semi-permeable. Semi-permeable, right? So the movement across the selective permeable membrane, partially or semi-permeable membrane, means there are some substances that can pass through, there are some substances cannot pass through. Usually, the small substances are able to pass through. All right. So small substances means there are some molecular weight. They will give you some molecular weight, and this molecule can go through, and that molecule cannot go through. All right. So this is the experiments about. Okay. So we highlight the title. All right. We highlight the title. Okay. Then go to the next one. Okay. Now, so what they do, they have a 50 ml of a distilled water. What is meant by distilled water? Distilled water is not mineral water, it's not tap water. It's the water that been boiled, all right, and then they drop out from the water vapor. Is the water pure 100%? Not really. They might contain ions. Okay, so if you want the pure water, it's not distilled water. It's called deionized water. So that is the difference between distilled water and deionized water. Distilled water is just that they're low in the ions. It's not much in the ions. Okay, so what type of ion? H plus lah, OH minus lah, some of the salts probably contaminated lah. So if you use deionized water, it's pure water. It's different lah. Okay, and 10 ml of iodine. Important. Why important? Okay, who can tell me what is the color of iodine? Iodine water lah. What's the color of iodine? Anyone know what's the color of iodine? Or not? What's the color of iodine? Iodine also don't know what color, then how to do experiment? Yellow, brown, so many color on. Okay, so some people will say yellow, some people is brown. So it's about that color. It's about yellow or brown. Okay, something like that. Can yellow or brown, something like that. Maybe I put it thicker a little bit, but not too thick. Yellow, brown, okay, yellowish brown, somewhere like that. Okay, yellowish brown. Okay, so initially you have a yellow iodine thing. Okay, you have a yellow iodine, you have a brown iodine. Okay, whatever you want to call. Now this brown, okay, is to test. Purpose of an iodine in your syllabus is to test the presence of starch. If starch is present, right? If a positive, we say positive test. If a positive test, that means it will turn blue-black. Okay, positive, it will turn blue-black. All right. So that's test for starch. All right. In some cases, they ask you, what is the Benedict solution, Benedict test? Okay, Benedict test, I don't know whether you will do or not, but it's so troublesome. Okay, you need to heat already, then you see the color brick red solution. Sometimes it's not brick red, sometimes it's orange. Okay, I did Benedict test before. You need to warm it. Wow, very troublesome. Okay, so this is easier. If the starch is present, iodines will turn, right, into blue-black from a brown or yellow or whatever you want to call it. Okay, so that's the iodine lah. Right. So in this case, I don't know what case you will get. Right. You will have a whisking tubing. This whisking tubing act. They will ask you what is the function of whisking tubing. Now, if they ask you what is the function of whisking tubing, how you reply, how you answer this? What is the function of whisking tubing? Anybody? No, not. Function of whisking tubing is what? Anybody want to try? What is the function of whisking tubing? Let me see your answer. Hey, very good. Just now I accidentally want to say out. Okay, what is the function of whisking tubing? Let me see. Okay, act as a semi-permeable membrane or act as a plasma membrane. Did they say about plasma membrane? They say about plasma membrane. You can talk about plasma membrane. So if they ask you what is the function of whisking tubing, it is act as a semi-permeable membrane. So they act as a semi-permeable membrane means they are something that can go through between the whisking tubing. Water can pass through. Big substances cannot pass through. There are some small substances can pass through. Big substances cannot pass through. All right. So what they put in a whisking tubing, if you need to do the whisking tubing is slippery. You touch whisking tubing before or not? Okay. You need to run down the whisking tubing about a few minutes, and then when you take up, very lichin. Okay. You very hard to tie up with the thread, very hard. Okay, unless you be patient, okay, don't panic, okay, tie it slowly and nicely. You will be panic. And slippery, okay, don't know how to catch. Okay, put in the starch already, suddenly slip off. So this is the starch. Starch suspension, 5 ml, 1% of starch suspension. Okay, let's say this question they put 5 ml of 1% starch. Starch is very, very big in the molecule. Right? Even you put water inside, okay, even you have a 1%, you just 1% only. Even just 1%, right? They will not pass through the whisking tubing. They will not pass through the whisking tubing. So starch will remain in the whisking tubing. And what will pass through? Probably water, probably iodine. Probably iodine water. All right? So that is a function of starch. Okay, there's a function of whisking tubing. Okay, to separate starch and the iodine. Right, you probably need to do the whisking tubing first, then you run down inside the beaker that with distilled water and iodine. But that one later we'll see the procedure. Okay, now they ask you. Okay, yesterday in the chemistry class I told you all. Okay, don't go and pandai look for the information here and write something manipulated, write something that have been responding. Whatever is responding, whatever is manipulated, look at the title. What they want to investigate. From the title, look at the experiment, look at the apparatus and material, and what is your manipulated, what is your variables. Okay, let's say, yeah. Okay. State the factor, right? State the factors that had been changed. State the factor have been changed. Have been changed means, right? Responding. Or sometimes they will call dependent variable. Okay? They use this kind of word, for example. Right? If this is a manipulated variable, is something that are independent. We call this independent variable. Right? Independent variable. So something that's fixed, that is called the constant variable. Okay? I said already, don't write the constant variable is temperature. Okay? Don't write the constant variable is atmospheric pressure. Okay? Don't write something like this. Even that is true, don't write. Because they didn't tell you fix the temperature. Did they tell you fix the temperature? No, they didn't tell you fix the temperature. Do they tell you to fix the atmospheric pressure? No. All right. We write something that is inside and affecting the solution. Okay. Right. So things have been changed over here. Don't read here and go and find out from here. From here first. Investigate the movement of the substances across. So if there is a movement, how do you observe? If there is a movement, you must observe. So the things that you can observe, all right, is the color change of the whisking tubing. All right. color change of the whisking tubing, or movement of the substances. It's good enough. Movement of substances is good enough. Right? What substances? You doesn't know who will be moving. Okay. So one thing about manipulation variable or responding variable is you don't know what will happen. Responding variable, manipulator variable is a guideline for you to write down the procedure. The experiment haven't done, you must have your manipulator variable and responding variable. Then only you do the procedure. All right. And that's why the manipulator variable and responding variable must come from a problem statement. Problem statement is your title. Right? You learn scientific approach, right? What is a scientific approach? Scientific approach say you must have a title first. So you look for the title. Right? After the title, you look for the hypothesis. After the hypothesis, you look at variable. After the variable, you look at the procedure, results, observations, and discussions, and so on and so forth. All right. So your responding variable must refer back on your title. All right, on your title. Okay. Don't go and think. Don't go and guess. All right. Constant. Now over here, constant. Right. Distilled water volume also can. Iodine also can. No problems. Right. So you can write volume of distilled water. Okay, can. Right. Volume of iodine. Right. Concentration. Starch concentration. Right? Starch concentration, as simple as starch concentrations. Okay, like this. All right, so this is about your responding variable, constant, and all this. Okay, things that you need to keep constant, things that you need to change, things that you need to observe the results. Okay, so next one, hypothesis. Okay, now I want to see, right, in this experiment, what is your hypothesis? You try hypothesis, and I tell you whether your hypothesis is correct or wrong. You surely done this in school, right? Okay, the teacher surely text you on, do this. So in this case, I don't know what case you will get, all right? Okay, probably this kind of case. What is your hypothesis? What is your hypothesis? Let me check. You can write in the chat box. I will see your hypothesis. I will read your hypothesis. I'll tell you what you need to change and all. What is your hypothesis? Or not hypothesis? Irina. Okay. Jane, later I come back to you. Okay. On a small molecule, this is true assertive, while large molecule cannot. Okay, Ishan, later I come back to you. Small molecule can go through semi-permeable membrane, while large molecule cannot pass through semi-permeable membrane. Okay. Some more, go or not? I want to see your hypothesis. Okay, one more. One more. Hypothesis is the guideline for you to draw out an experiment. You look at the title and you look at the experiment, you specify item. You specify item. What you think the result will be in this experiment. This is a hypothesis. Again, you change a little bit. You see, what is the result that you think? Okay, before the experiment, you think before the experiment, what you think at the end of experiment, the result will be. Okay, so they are, okay, no, so your one, you cannot put if. Okay, when you do an experiment, if this one, if that one, no. You want to see whether this one can be proven or not proven. Hypothesis at the conclusion can say the hypothesis is not accepted. So hypothesis is a smart guess. It's not whether this one or this one. So that is the if I want you to remove. Okay. So Yushen, you just put it in more details. In this experiment, what you will expect? What you will expect the movement of the substance across the semi-permeable membrane in this experiment. Who will move to who? You can specify. Okay. Small molecule can go to. Okay. So I know your meaning already, right? I think your perspective is correct, right? Just a little bit corrections. Okay. Hypothesis is a smart guess. Remember this. Smart guess of what? Smart guess of result. Then you do the experiment to prove your guess. Okay. For example, I say, I think, for example, I think Aaron is the smartest. So I need to do a test to prove he's the smartest. So after I do the test, he's not the smartest. At the conclusion, I say, my hypothesis is rejected. So you must give a direction to do that. Okay, so my hypothesis is, all right, don't straight away write, oh, this one will turn blue-black. Turns blue-black is the title say there's a blue-black or something. No, the title say what? Movement of substances. So you talk about who can move to who cannot pass through to who. Movement, right? Movement, don't write color change, don't write color change, write movement. Okay. For my hypothesis, starch is unable to pass through whisking tubing. They are not. Okay. Straight away, don't write semi-permeable. Straight away, point out in the experiment what you want to do. Or this one enough for to get 3 marks. Or iodine able to pass through the whisking tubing. No need say semi-permeable. Straight away put whisking tubing. You understand, right? Let me check. It's not blue present. Only small molecule are able to pass through. Say this one large molecule cannot. Okay, what you say is correct. It's 100% correct, but I want you to specify to the experiment. Okay, specify to the experiment. I think it's overall it's good. If you ask me, I give you 2 marks. Okay. Can hypothesis? Any question? Rendamkan whisking tubing dalam. All right, ladies and gentlemen, let's move to the next question. Let's move to the next question. All right, what does the next question say? Anda dihendaki menjalankan eksperimen seperti langkah-langkah di bawah. Okay. Rendangkan whisking tubing dalam 5 minit untuk menembukkan. Okay. Lembut after they've been softened you cannot catch one. Okay, cannot catch one. So you tie the whisking tubing at one end. This is my biscuit. Okay. We tie the whisking tubing at one end. Whisking tubing is not that nice. I mean, it's not that nice, hard like that. Soft one. All right, soft one. We tie at one end. Okay, and then you put whatever kanji 5 ml 1%, and then you tie at the other end. Tie the other end like this. Okay. Like this. Tie the other end. Okay. So after that, you wash a little bit on outside. Wash a little bit. Okay. Don't scare the water will diffuse in. The water will take some time to diffuse in. So wash, wash, wash. After that, you put in the beaker that with iodine. Number 4. Beaker that with iodine, you rendam inside. Beaker that with iodine. All right. As a diagram 1.1. Important stopwatch. Okay. Look for all your apparatus. Where is your apparatus located? Where is your beaker located? Where is your what do we call solution located? Don't go in when you want to do where borrow. Okay, in front you cannot see. Okay, go and see other people's one. So make sure you know location. Everything's located. Okay, now you want to do, you imagine first, want to do this, want to do that. Okay, stopwatch, remember. After 10 minutes, remove the whisking tubing and place in a dry beaker. So you just follow lah. After 10 minutes, you remove the whisking tubing, place in a dry beaker, and see, right? And see what? See the color change in whisking tubing. See the color change in the beaker. See 2 things. Beaker got change color or not? Okay, you want to make sure whether the starch can come out, because now you do the experiment. All right, you will need to know whether the starch can come out or not. So you put there observation in the beaker, observation in the whisking tubing. Okay, observation in the beaker, observation in the whisking tubing. All right. So and then your tight your knots be tight enough, because this is a slippery. Your knots, right? Your knots okay. I warn you first your knots can happen or not? Happened before. You tight, right? Slippery. Whisking tubing very slippery. Okay. Okay, record observation. Okay, look at this. State the change of the color observed in the whisking tubing. Okay. Very sticky. Yeah lah. Yeah, they collapse. They collapse. Right. Your tight knots remember your tight knots okay. You know how to tie knots Okay, what I want to say. Color change in the whisking tubing. Okay. Remove the whisking tubing means you need to pour the solution. Okay. You need to pour solution or not? You see got right there. Remove the whisking tubing from the beaker and put in the dry beaker. Okay. Like that. That's it. You open already, you want to put where? You open already, you want to put where? You open already, you want to put where? To pour in the beaker and then whisking tubing. Okay. Okay. Let's see. What is the color observed? What do you think? Now you never do the experiment, but you can imagine. You can imagine. Okay. What is the observed in a whisking tubing? What do you think? Imagine. Okay. So now, okay, imagination important. Even though you haven't started the experiment, but you must have a little bit imagination. This is hypothesis. Here you have a starch. Here is iodine. Right now. So you got starch and you have an iodine here. All right. So what will happen to the observation? What do you think they will change? Cloudy can, no problems. What color? What color they will change in a whisking tubing? Okay, let me ask you a question. Let me ask you a question. You say brown color turns into blue black. Does the whisking tubing from brown color or not? Who did this experiment before? Tell me, what is the color of whisking tubing initially? Does the brown color, does the whisking tubing is brown color? You say brown color, you check whether your whisking tubing is from brown color or not. Check betul-betul. If you write blue black, the whisking tubing is blue black color. Okay, no problem. Right? So from cloudy, you put kanji powder, kanji powder. They are like white color watery like that, right? From cloudy, right? Change to from cloudy, change to blue black solution, right? From cloudy, change to blue black solution. Give me a minute. Blue black color, not solution. All right. So your iodine is brown, but iodine is in where? In beaker. Okay, iodine is in beaker. Don't write iodine beaker, one go into the whisking tubing. So iodine brown and iodine diffuse, okay, into the whisking tubing and go into the content, and the content change color. Right, and the content change color. Right. Okay, so explain the observations based on your answer C1. So what is your answer for C1? Explain the observations. So if you don't know what to explain, look back the title. Title say, investigate the movement of the substances across whisking tubing. So whatever you write have to refer back into the movement of substances across. Okay, yesterday got one student told me, wow, something really out of a movement of substances. Okay, they say what? You know what I say? Because I give you a wrong answer. You might give this answer in exam, but I don't want you to write something like this. Okay, what you might give, right? In an exam, people will give this answer. Because iodine react with starch and form blue black, to form blue black. Don't put this answer right now. Don't put this answer. Remember, don't put this answer, because they are students. They say, hey, why the change to black color? Because iodine react with starch be blue black ma. So iodine react with starch is blue black lah. My goodness. Okay, my goodness. It's not. So whatever observations or whatever result that you need to explain, okay, look back the title. Is this relate to the title? Okay, go back to the title. The title say what? Movement of the substances. So over here, your explanations have to be movement of substances, right? Follow whatever is in your title. Title very important. Title very important. Okay, so right there. This is because iodine, movement of substances, don't write there. Iodine move. Okay, iodine does not move. Diffuse. Iodine molecule diffuse across the whisking tubing. Number one mark. Number one mark, write diffuse. What is meant by diffuse? Diffuse is not active transport. Diffuse is something that is from more substances go to the less substances, high concentration go to the low concentration without any ATP. Facilitated diffusion, whatever diffusion, simple diffusions, no energy, no ATP, more concentrated, go to less concentrated. That's it. Iodine diffuse across the Whisking tubing, okay, due to its small size, due to the size of the molecule, due to the small size of a molecule, right, and change the starch suspension. Now only you change the suspension to blue black. Yes, iodine turns the starch into blue black, but what does the question want? Look at your title. Your title say movement of substances, priority on the movement of substances. Right? Whisking tubing is a semi-permeable membrane. What they want? They want your movement of substances only lah. Correct? They just want your movement of substances. That is a priority of answering the questions. Right? Your priority of answering the questions. Okay, good. Can I? All right, go to the next one. Based on the experiment, state the operational definition of a plasma membrane. Okay. Now, you do any of the experiment, you will come out with operational definition. Right? You will come up with operational definitions. Right. Tell me, how do you write operational definition? You can write for me. Operational definition for what? For plasma membrane. So your answering have to be plasma membrane is start. Try. Surely your school teacher got teach you operational definition. I also got teach you before, but a few months back. What is your operational definition? Or not your operational definition? What you want to write? Try. Just try it. No issue one. Okay, you don't try it, you don't know, you wrong ma. You wrong also, you don't know. Then you go to the exam, you write the same thing. Die. You listen here. Oh, I know. It's okay. Okay, it's a membrane. Now, small membrane. All right. Pass through it. Okay. Lai Yong, you get a good explanations, right? You get a good explanations. Yeah. Okay. Use this word diffuse. Diffuse. Mana diffuse? Okay. Diffuse. You can say pass through, no problem. You can say move, no problem. But I want it to be more, this one, to be more specific. Okay. Okay. Jane. Okay, very good. Which is more good. Hey, what you say is a normal definition. Normal definition, 1 mark. But I want operational. Operational means what? Operational means in this experiment, what can be proved as a plasma membrane? That means I know plasma membrane. Okay, plasma membrane is something like this. In this experiment, okay, which thing similar to plasma membrane, which thing have been done is a plasma membrane? No. Specific. Okay, plasma membrane. You can say plasma membrane, it's molecule. All right, plasma membrane is not a living thing, it's a molecule. All right, it's selectively permeable. You can write semi-permeable. You can write what? Partially permeable. Up to you. Permeable membrane. All right. And that only allow certain molecule, or in this case, small molecule. You don't know how to write, never mind. Go here. Never mind. Okay. I don't want to teach you some shortcut. Okay, I want you to go pass through the whole thing. Okay, then only allow, all right, small molecule For example, A full stop G. Okay, iodine. To diffuse through. Okay. All right. Okay. Going to this one. Can So you must write something that related to the experiment. You must write something that used in the experiment. Okay. It's a semi-permeable membrane. How do you prove in the experiment? I see iodine move through, and that is operational definition. These are definitions, and these definitions operational. In this experiment, they proved it. In the experiment, they proved it. So that is something related to operation definition. All right, ladies and gentlemen, classified material and apparatus. So you have to tell what is the materials and what is the apparatus used in the work. Okay. Okay. Now, how do you know this is a material? How do you know this is an apparatus? Okay. Now, many people will tell you, if you use one time, this is a material. If you use many times, okay, if this can be repeatedly used many times, this is then will be an apparatus. Okay. This saying is correct halfway. If you are lazy to think about what is material and what is apparatus, correct halfway. Okay, but what really is a material and apparatus? If you use this, what have been done, use one time and throw. Filter paper is what? Filter paper is a material? It's not. Filter paper is an apparatus. Filter paper throw one time or not? Use one time and throw disposable? Yes, this is disposable, but this is not a material. Right? So, material is something, right, that you want to use it and got the result and look at the observations and you see that. Okay, it's like you're cooking kway teow, right? Your material is water lah, material is soy sauce lah, what sauce lah, okay, chicken lah. These are all your material. Then your apparatus is the quality. Your apparatus is the one that help you to success the experiment, to help you to do this experiment. So your experiment is to prove the movement of the substances, right? So your material, you need VIsking tubing. Your material is a starch, right? Your material is an iodine, right? Move across the plasma membrane or not? Move across the plasma membrane. Water, is it movement across the substances? Is this all involved in across the substances? Yes, it is. Then you go to the helper part. Helper part is the apparatus. Okay, what you use? You use clamp lah, forceps lah, retort stand lah, conical flask lah. So that is nothing to do with the movement of particles. There's nothing to do with the movement of particles. Then you do beaker, okay, measuring cylinder, and a stopwatch. What else? Okay, and what the benang that you tied it, all right, there will be a thread. These are apparatus. Thread throw one time or not is also throw. Okay, but materials is you look at something related to the title of the experiment. Title of the experiment is what? Movement across the substances, across the plasma membrane, semi-permeable membrane. Okay, understand? Okay, so not everything used one-time throw is a material. Majority, yes, it is, but is related to the experiment one. Everything that used to related to the experiment you see across plasma membrane, that is a material. Okay. Okay, one more question. G. Okay, I want you to think about this. This one, all right, nobody knows. Okay, it can be something like that. It can be something like that. Right? We don't know. Right? We don't know. Okay, because this is a prediction. Okay, your apparatus have been set up earlier. All right, I guess Monday they will start to set up your lab already. Okay, but the questions they will ask you to do, the ramalan, the question they ask you to do, all right, you don't know. Right, predict what will happen if the starch suspension is in the beaker while iodine solutions are in the whisking tubing, are at the out whisking tubing. There are one questions. There is a one questions they will ask something like this, right? Your textbook will never find. You need to think out of your textbook. Okay, what do you think? What do you think is the observation? What they want is the observation lah. Okay, what you want is the observation. Don't write something funny. Okay, what do you think? Try this question. G. Use the theory, use the color that I teach you, use the movement of substances, then you can answer this question already perfectly. And read you tell me that I will read one. Okay. Okay, explanation. Okay, your prediction is good already. Explanation, you left explanation. Explanation. Prediction is good. Jane. Starts of a bigger. Okay. Okay. Explanation. Okay, good. Ayong. Turns from cloudy to blue instead of whisking. Okay, no need instead of. No instead of, because it's a new experiment, and then do explanation at the bottom. Okay, what is your explanation? What is your explanation? So, okay, your prediction is just like this. The beaker will turns into blue-black solution. Right? You want to write from a cloudy? Okay, no problem. Can go ahead from a cloudy. Okay, I read. So it is out the semi-permeable. Very good. Perfect. 3 marks. Perfect. So now you know how to write explanations. I want these explanations all along from A until G. All right. You need to specify. Okay, because this is a paper 3. Paper 3 cannot talk general. Small molecule can pass through. Small molecule, who is small, who is big. Iodine, starch. Paper 3 need to tell directly. Iodine or starch. Can I say, oh, small molecule. If this is present, no such thing. Directly one. Okay, I think use because causes solutions. Okay, very good. But never mind. This is good enough. License. Perfect. Jane. Needs to be as a semi-permeable membrane, able to diffuse through a semi-permeable. Okay. Like okay, membrane. It's going to be a small molecule able to diffuse through the membrane and react with who? And react with starch. Okay. Explanation. Iodine molecule. Okay. Diffuse. Right? Diffuse. What they say? Iodine solution from the whisking tubing out to the starch solution in the beaker. Okay, I want you to highlight this. Diffuse must write from where to where. Okay, pass through from where to where. Okay, from where to where. You can say diffuse out, no problem. Diffuse out, no problems. But diffuse out means got from where to where, right? So I want you to say diffuse direction. Okay, diffuse out semi-permeable into a beaker. Like this, correct? Okay. Okay, then this is your second mark. Your third mark, right? Diffuse out from where to where, right? And react. Why they turns blue-black? You have to explain about your blue-black. Okay, explain about the blue-black. And react with starch. Okay. And react with starch to become blue-black solution or blue color, dark blue color solutions. Okay, blue-black means dark blue lah. Solution. Becomes dark blue solutions, give you marks. React with starch, remember. Okay, dark blue color come from where? Come from reactions of iodine and starch. Okay, diffuse from where? Why they can diffuse? Because it is small molecule. Do you need to explain again that it is a small molecule? You don't have to. Why? Because previously you already explained about your small molecule. No need to explain again. Short sentences. Don't write sentence, okay? I warn you first. Don't write sentence over here. Please don't. Okay? If they are happy, they read it. If they are not happy, they can not to read it. Okay? Don't write over. Don't draw your own line. Ding, 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 ding. You draw your own line. Okay? Why? I saw people do before. I saw people do before. All right? Can Okay. So until here first, and next week we talk about our Ramalan questions, right? Of the structure essay, especially lah. Right. I will see you all back to next week, and good luck for your paper 3, everybody. All right. Finger crossed. Thank you, everybody. Bye bye.
All right. Thank you, teacher.
Bye.